because, yeah, and then let's just add that here. We're going to have halfway here is going to be 52.5. Now, my graph isn't like perfect as far as like drawn to scale or whatever, but I hope you're starting to see how if you're modeling the height versus time of a Ferris wheel, you're making a sine wave. And this thing is just going to keep going all day, and people get in and out and in and out, and so this is just going to keep going and going and going. And it makes a sine wave. Ta-da! Now, your job is to come up with the equation. Once you have the graph, the equation isn't actually that bad. Okay? So I'm going to kind of scroll down here. What did we already said what the amplitude was. What was it? 60. So I'm going to come right here. The amplitude was 60. And we're going to be doing this with a sine curve, okay? Because sine is like the one that like, we could do cosine and sine. They're basically the same except a phase shift. But we're going to do sine. Now, what else do we know about this one, okay? If we're looking, our next letter is B. And what does B go with? What's your formula for period? Period is 2 pi over B. Now, we actually know what the period is. What is it? 30 minutes. That's the length of one cycle, which is 30. So I'm going to put 30 is equal to 2 pi over B. So what we need to do is figure out what value of B would give us 30. So we're going to do some algebra here, and we're going to try to solve for B. If B's in the denominator, what's a good first step? Let's multiply by B on both sides. So that gives me 30B is equal to 2 pi. What's going to be my next step here to solve for B? Divide by 30. So I'm going to get 2 pi over 30. Can I reduce that? So that's going to be B is pi over 15. So we're going to have 60 sine, and B is pi over 15. What's up? Let me see if this person's here. Yeah, I'll give that for you. Okay, thank you. Thanks. Okay, I'm going to come back to the phase shift here in a second. Let's talk about K. What did we say K was? It's not necessarily the height. It's, if we go back to the midline. Now, this is where some people mess up and they say, oh, it got shifted up 15. Now, that's the bottom, right? The midline is going to be the midline, the middle of it. And what did we say the midline was? 75. Because sine and cosine, right, the midline's right here and then it goes up and down. So it got shifted up 75. So that's going to be plus 75. Okay. Now, our last one is phase shift. And what that's going to be is, this doesn't look like a sine wave, right? At least of the parent function. When I graph the parent function, where does sine start at? 0, which is its midline. So we're used to sine starting right here. But it doesn't start right there, right? It got shifted over a little bit. How much did it get shifted over? So what I'm going to do is I'm going to start at the midline and just draw a line to here and draw that down. And I could say, hey, this looks like a sine wave, but it got shifted to the right by how much? 7.5. Good job. So now, if I wanted to make it go right, what do I need to remember to do here? Subtract, because it's opposite. So I'm going to do minus 7.5. And voila, you have your equation that's going to model this. Okay? Now, let's just review it real quick so we're all on the same page. What does 60 represent? Amplitude, because from its midline it went up 60 and down 60. Awesome. Pi over 15. This is what gives us that the period is 30 minutes. What we did is we took 2 pi over b. We said the period is 30, and so we worked backwards, solved for b, and we got pi over 15. This is how we make sure the period is 15. This was just shifting it over because sine normally starts here. We wanted it to start there. And then the 75 is the midline, that's how much it got shifted up. How are you going to check your work on this? On your graphing calculator. Okay, but what I want you to do, so first off, you want to be in radians. So when you get your mode set to radians, go into your y equals and plug it in. Did you already plug it in, Hiram? And then I'm going to show you on mine as well to make sure we're all on the same page here. Now, what do you use instead of theta? Just use x. Good job. Okay, wait for it. Okay, now when you guys go to graph this, you might not be able to really see it as well because of your window being not where it should be. So when I go to graph this, this is what mine looks like, and I can't really see what's going on as well. What I need to do is I need to change my window. Let me change some other things. Okay, so here's what I want you to do. Go into your window, and we're going to change the x min, sure that's 10. But when we looked at our graph, how far did we go out? Let's go to 70 so we're a little bit more than that, okay? Now for the y minimum, we went, let's just do from negative 10. How high did we go up? So maybe like 150, does that work? And if you want to change your scale, we can do that. Now, if I put it in all right, maybe I put in, let me check something. 60 sine of pi over 15 times x minus 7.5. Oh, plus 75. That'll make a difference. So now when I graph it, does it look like what we were coming up with before? Let's trace. So push the button that says trace. And what it's going to do, let's start it at 0, and we're at 15. At 7.5, we should be halfway up at 75. After 15 minutes, we're at the top, which is 135. 22.5, we're halfway down at 75. And after a half hour, we're there. So guys, you just came up with an equation that models the height versus time of the Ferris wheel using a sine wave. Wasn't that neat? Okay, I want to come around. So what I want you to do now is check with your neighbor to make sure you got this. And then if you need help, or if you're like, mine doesn't look like that, call me over so I can help you, okay? Mine does. Okay, let me check your equation first. So you need two parentheses here. Because yeah, one open, one open. Here we can put it. I don't know.
Maybe just your window.
Now, how does it work? We needed to go here. Let's put a 7. Oh, there. Okay, so now you're okay. Anyone else need help with their calculator? So I think, let me see if that makes a difference. think it's because you did. There we go. I think you just switched the 70 and 150. There we go, that looks better. By the way, guys, on your equation, I have, if you do 2 parentheses opening, you got to do the 2 parentheses closing. That's been a mistake on some, so that might be it. Okay, we're going to do another one, and then we're going to get into an activity for you guys to try out, okay? Okay, trivia. Where is the world's tallest Ferris wheel? Anyone know? Where, Brenda? Las Vegas. Anyone else have a guess? France? London. It used to be the world's tallest in London. And guess what? Brenda was right. Brenda, how'd you know that? You've been on this Ferris wheel? Awesome. Okay, this is called the High Roller, and it's in Las Vegas, and it's the world's tallest Ferris wheel. Apparently there's another one that's under construction in like China or somewhere, but it's currently like halted construction, like they started it and they're like, yeah, we don't have the money for this. So still the world's tallest one, okay? So if you ever go to Vegas, you should go on this. It's called the High Roller, and it's the world's tallest one. So a few years ago, I was in Vegas and I'm like, I need to go on this so I can tell my students I've been on the world's tallest Ferris wheel. So that's me and my family. And this was the view from the midline. And then let me show you, I'm going to go to these other ones. This is how it gets on. Like people are like, how does it continuously go around? And what it is it has the sliding doors on the front and back. And so it'll open and the people go out while the new people go in. But it's still moving. But they have a net underneath, so if you like fall, you don't die. So that's cool. And this is what it looks like from the top. We went during the day because it was cheaper. Obviously, it would look a lot cooler at night. All right, so what we're going to do now is let's try to come up with the graph and the equation for the high roller, all right? All right, let's send this one to Allie. Will you just read that for us? Okay, great. So when we're looking at this one, what are some similarities? What are some differences? Similarities. So we're still graphing height versus time. What else? Between the Ferris wheels. Is every 30 minutes. So the period is 30 minutes. What does that tell you B is going to be here? Thanks, Josh. Pi over 15, okay? Now, differences, what's a difference? Yeah, well, we switched from meters to feet. So the other one was 135 meters. Now we switched to feet. And 50 feet is higher than 135 meters, but that's going to be a little bit different. So here's what I want you to do, is I want you to label where the highest point is and where the lowest point is. See if you can gather the data from this, okay? And then see if you can figure out where the new midline is going to be. All right, someone tell me what just by reading, we know the highest point is 550, right? Where does that mean the lowest point is and how'd you get it? What do you think on this, Peyton? What'd you get? Awesome. Okay, so there we go. Very similar to last one. And how would we figure out where our new midline is? What's the halfway point between 550 and 30? Did you figure that out, Peyton? Great. How did you get that? Which is 260, right? Awesome. So I'm going to write that in here. So this distance right here is 260, and this distance here is 260. What does that mean 260 is? That's the amplitude. Awesome. Okay, so now, guys, that's basically enough for us to figure out the rest. So 290 is our new midline. 550 is our maximum. I kind of draw this so I don't get skewed as we're going. And 30 is our minimum. And it doesn't help because I'm already up. Okay, let's try that again. Now, just like on the last one, this timing is the same. It's going to take 30 minutes to complete one rotation, and 60 minutes if we're going to go through two. So let's just talk about the first. When are we halfway up? 15. When are we at the midline? 7.5, and then 22.5. Same thing, let's go from 30 to 60. Halfway is 45. Half of that is 37.5. And then half of that is 52.5. Yo. Oh, we got singer people?
We're here for Nathan and Charlie.
Woohoo! Come on up.